let's say we ask a particular question about the two layout simulations. Let's say we want to know if layout B produces more than 50 pallets a day more than layout A. That is, we don't want to just test if layout A and layout B produces more than A. We want to know the extent to which it produces more than A. Okay? Is it producing more than A by over 50 pallets? Okay, so again, let's refer to layout A as population 1 and layout B as population 2. Okay? And we want to know, is layout B more than layout A by more than 50 units? Okay, so this is kind of confusing, but follow with me here. So we want to know, is this difference less than negative 50 units? Okay, that's saying, is this number bigger than this number by more than 50? Let this number minus this number less than negative 50. Okay, we just got to keep that in our minds. Okay, we want to know, is this number bigger than this number by more than 50? So if we make that subtraction, that would be less than a negative 50. Okay, but it's just easiest for pedagogical purposes to keep using the same population 1, population 2 notation. Okay, so more than, okay, this bigger than this by more than 50, more than would imply strictly more than. Okay, since we're turning it around, it's going to be strictly less than. So that must mean that the equality statement must be in the null. And the equality statement must be the contradiction of this greater than or equal to negative 50. Okay, so this is the set of hypotheses that we want to address here. Okay, so we just need to calculate what our test statistic would be. Okay, the test statistic, pretty straightforward to calculate. It is the difference in sample mean throughputs in pallets per day. That difference minus the difference in means, population means that we want to detect. Okay, in this case, that's going to be a negative 50 right there. We're going to divide this by the standard deviation of the sampling distribution. That is S1 squared over N1 plus S2 squared over N2. Okay, so whenever we work this out, we've got Y bar 1, or Y1 bar, that's 1284.4. We're going to subtract from that 1548.3. Okay, and how different is this from this hypothesized difference? Negative 50. Okay, we're going to subtract off a negative 50. And we're going to divide this by standard deviation units. Okay, so that is 369.4 squared over 30 plus 259.7 squared over 30. Okay, so how different is the evidence from the hypothesized value in standard deviation units? Whenever we work that out, we get a value of negative 2.595. Okay? And remember from previous, we did that nasty, hairy equation for the degrees of freedom, and we found the degrees of freedom was 52. So the p-value here, note this is a lower tail test, so the p-value is going to be in the entire lower tail. Okay? To calculate the p-value, we're going to use Excel. We're not going to find this exact degrees of freedom in the t-lookup table. So we're going to use the tdist function in Excel. And it wants to read in a value on the axis, but it has to be a positive value, so 2.595. And then it wants the degrees of freedom and whether or not this is a one or a two-tailed test. This is a one-tailed test here. So we're going to put in the value 1. Okay? So whenever we enter that into Excel, we get the value returned to us as 0.006132. Okay? 0.006132. Very small number. Okay? Much smaller than any alpha we would ever choose. Okay? P-value smaller than alpha. We reject the null and conclude that mu1 minus mu2 is indeed less than negative 50. Okay? What that says in the language of our problem is that the throughput of layout B is greater than that of layout A by more than 50 pallets per day. Okay, that throughput size for layout B is greater than that of A by more than 50 units.